Hello friends, welcome back. In this session, we are going to learn and understand the prevention and detection techniques. Yes, that's the stage we are in right now. First and foremost approach is to follow the secure design practices. Yes, we should have secure design practices in place to reduce the Trojan injection risk at the blueprint level itself. We can go ahead with careful verification techniques, careful control methods at each stage of design, and we can ensure we have got safe systems in place. We can have design validation and verification in the first point, where we can conduct thorough simulation and validation steps to ensure the design performs as expected without any element of suspicion. So we need to go ahead with thorough simulation, I repeat it. Followed by that, we need to have proper validation steps which can ensure that what we expect is what is there. Second is formal methods. We can use mathematical verification techniques. It's going to be always supportive, and mathematics is going to handhold us even here. The mathematical verification techniques can be used to detect the inconsistencies that could indicate a Trojan. Thereby, we can eliminate it. And finally, we can go ahead with IP authentication approach as well. You can verify that the IP, the intellectual property cores used in the design are free from tampering. Because I explained you the types of a Trojan insertion possible, and one is at IP level itself. So if you can verify that the IP that you are using, that the IP core that you are using is free from tampering, you can be confident that it is a Trojan free design. So we can follow design validation and verification. We can go ahead with formal methods. We can go ahead with choosing the right IP core which can be used in our design. The second very important thing we can look into is the trusted foundries. What are they? They are nothing but the vetted and certified manufacturing facilities. These facilities are trustable. They follow strict protocols. And through the strict protocols, the intrusion or unauthorized access during the production stage is avoided. Trusted foundries implement very stringent, strict security check. They have enabled superb access controls, and the employee background checks is also important, which has been done in this trusted boundaries. That way, the likelihood of Trojan insertion can be reduced. For example, you can use a government certified foundry for defense equipment manufacturing to ensure that safe and Trojan free production is made through the foundry. So choosing the right one is important for you to make the right one. Split manufacturing is the next very important thing we can look into as an option. In the split manufacturing, a chip's layout is split and sent across to multiple manufacturing facilities, which means we are not dependent on one single facility for manufacturing. No one facility has got complete design information is the key point to be understood here. So by this way of splitting the design, each facility has got knowledge and they know only about one part of the layout which they are working on. So it will be very difficult for the party to embed a Trojan into entire design. You are avoiding them from knowing the complete design, and still the complete design is scattered across multiple facilities, thereby you are protecting them. So you are sending different sections of a circuit design to multiple manufacturers, ensuring that no one facility has got access to the entire design, and thereby we can strongly trust that the design is safe from Trojan injection. And physically unclonable functions. We call it as PUF. PUF fundamentally uses physical variations of each chip, unique physical variations of each chip as a fingerprint to verify the authenticity and detect tampering. Please understand, it uses unique physical variations of each chip as a fingerprint. That's going to be used to verify the authenticity and to detect the tampering. Each chip has got unique physical properties. For example, microscopic imperfections. And they generate a unique signature that can be checked to ensure that the chip has not been altered, the chip has not been tampered, the chip has not been changed. So, this is very important approach as well. Verifying the authenticity of the chip before deployment by checking the unique PUF is a simple approach where you can ensure that it is not altered. This is one of the very important. Regular audits and testings. Yes, this is something unavoidable. We can conduct regular audits and post-manufacturing tests to ensure that has it happened in a way that is not acceptable. Do we have any unauthorized modifications? You can analyze and test all these things. So random sampling and testing is one of the very important techniques that we can follow. Regularly testing random samples of manufactured chips for anomalies can definitely indicate tampering. That way, we will be able to identify if some mishap has happened. And high security testing for critical components is essential. We can apply side channel analysis, electrical testing, optical inspection, and it can be done in a much more rigorous way as well on the critical components that we are looking at. For example, you can conduct extra rounds of logic and side channel testing on the chips used in military equipment. That is very sensitive, so we will have to do it that way. Audits and testing are really helpful. In the next session, we will be able to understand the challenges that we face in detecting the hardware Trojan. I hope you like the content. If you like the channel content, kindly subscribe. Thank you.